All right, so let's go over all of our kind of mathematical properties that we've got. People think that in math there's so many rules that you've got to memorize and know, and really there's not. For everything that we're going to be doing in algebra, it's pretty much governed by 7 properties that we're going to have. And we think of those 7 properties as really being rules of the game. And so they're telling us what we're allowed to do. We can really think of them as the rules of chess. For that, you know how each piece moves in a particular way. Same thing is going to be true in algebra. Each rule tells you what you are legally allowed to do. As long as you follow those rules, you are free to make any move that you want to. And so we actually have quite a bit of freedom as long as we follow the rules for how we're allowed to move. And so for that, let's start looking at the first rule that we have, which is called the commutative property. Now we're going to have one commutative property for addition, which is basically just going to say if we add a plus b, that's the same thing as b plus a. Now we're going to have a similar one for multiplication, which again is just saying that a times b is going to be b times a. Now the associative property, once again we're going to have one for addition, and so the one for addition is really going to tell us what happens when, if we look at this, the left hand side is saying if I want to add a and b together and then add c, and the right hand side is saying, all right, I want to add b and c together first and then I want to add a. Well, what the associative property is telling me is that, you know what, it's absolutely fine. Whichever way you choose to do it, you're going to get the same answer, that those two relations are going to be equal. So we've got an associative property for addition, we've got an associative property for multiplication, and it's pretty much just saying the same thing. If I've got 3 things that I'm multiplying together, I can either multiply the first 2 and then multiply the third, or I could multiply the second 2 and then I could multiply the first. Again, the associative property tells me it doesn't matter how I choose to do it, I'm going to get the same answer either way. And so those are 2 very nice properties that I can have for addition and multiplication. Now, something that we will notice with those is that I've got a commutative property for addition, commutative property for multiplication. I don't have one for subtraction, and I don't have one for division. The reason for that is because they don't work. Those properties really don't hold. The commutative property for subtraction would say something like 2 minus 3 is 3 minus 2. No, that's not true. And so we don't have a commutative property for subtraction because it's not a nice operation. Same thing for division. Division is again not a nice operation, so we don't have a commutative property for division. We don't have an associative property for subtraction. We do not have an associative property for division. So addition and multiplication are 2 really nice operations, and that's why for everything that's going to follow, everything will be done or talked about or thought about in terms of addition and multiplication. Okay, so for the next property that we have, it's the distributive property. And so the distributive property is there to tell me that if I've got so if I'm over here on the left, it would tell me to add 2 things together and then multiply by a. Well, the distributive property says that if I want to multiply first, I'm going to multiply each term in the parentheses by a. And that's how I can kind of reverse. Here I would add first, then multiply. On the right hand side, I would multiply first and then add. And so the distributive property tells me how to do those, kind of interchange those 2 operations and still have everything be equal. All right, so the next property that we have is the identity property. Now, what the identity property basically says is that we've got the existence of 2 numbers, 0 being the additive identity, which basically means that it's not going to change the identity of any particular number. That if I add 0 on to any other number, it's not going to change it, and I'm going to get that same number back. So basically, a plus 0 is a. And so if 0 is going to be the additive identity, then I've got another number, namely 1 is what we call the multiplicative identity. And so basically that just means that if I multiply by 1, then it's not going to change a number's identity either. It's not going to change the number at all. And 1 times a is just a. So the next property that I have are the inverse properties. Now the inverse properties really say that I've got numbers that kind of reverse other numbers. So every number is going to have an opposite. It's going to have a number that can kill it off. And so the number that's the opposite, or the additive inverse of a, is just negative a. If I add a onto, so a plus negative a is going to give me 0. If I do negative a plus a, that's also going to give me 0. So it's got a number that if I add it together, then they will cancel each other out. Now the same thing is going to be true for multiplication as well. So, but that's going to be true as long as I've got every non-zero number. And so every non-zero has a multiplicative inverse, and really the multiplicative inverse is the fancy name for just saying I want to take the reciprocal. So if the additive identity is the same thing as the opposite, the multiplicative inverse is just the reciprocal. And so if I take a number and take the reciprocal of it and multiply it by the number, I get 1. And same thing, if I take 1 over a times a, that also puts me back to 1. And so that tells me that every non-zero number has a number that will cancel it out in terms of multiplication. And so I'm thinking of the inverse properties. We're going to really get a lot of use out of them when we're solving equations, as being able to reverse the operation of addition, or to reverse the operation of multiplication. So our next property that we have, or the rule of the game, is something called the addition property of equality. Now this one is a little bit different than any of the other properties that we've seen before, because it's really an if-then statement. And so what it's really going to say is that if I start with two things that I know that are equal, then I can take any other number c and I can add it to both sides, and that will maintain equality. So this tells me kind of what I'm allowed to do, one thing that I'm allowed to do to keep things equal. So if I start with something that's equal, if I add the same number on both sides, it continues to be equal. So I have this property for addition. I also have this property for multiplication. So I've got the multiplication property of equality, which is going to pretty much say the same thing, that if a is equal to b, then if I want to multiply by c on both sides, then I maintain that equality. So if a is equal to b, then a times c is equal to b times c. Now, these two properties in mathematics are known as if-then statements. And kind of the big thing about if-then statements is that's what we use to kind of chain together things that are true, so true statements that get put together in logical arguments, or to be able to make inferences on things. And so kind of what you might be thinking there is you are doing a logical argument, just like you are doing a logical argument in philosophy, or you are doing a logical argument in apologetics, so that if I want to be able to take one statement and infer something about it to the next statement, and to put my chains of truthful statements together, develop a coherent logical argument. Well, that's what the addition property of equality and the multiplication property of equality let me do in mathematics. All right, so let's apply the addition property of equality with 2 to an expression that we have. And so the expression that we'll start with is just going to be x is equal to 3. So now the addition property is just going to tell us that if we add 2 to both sides, then it maintains equality. And so let's see what the answer to this might actually look like. So we start off with x is equal to 3. And this arrow that we have here is kind of the mathematics way of saying the then. So up here we don't really say the if. So if x is equal to 3, then what's going to happen? And so what does the addition property of equality have to say about this? So this if x is equal to 3, then what do we have? We can apply 2 to both sides. So I'm going to add 2 to the left side, add 2 to the right side. That's what the addition property of equality is telling me, that those two things are actually still equal. And so what I could do then is to take this 3 and this 2. Now I can put those together to end up giving me just kind of our final answer for x plus 2 is equal to . All right, so now let's apply the multiplication property of equality to an expression. So let's use 3 now in this case, and we're going to apply it to the expression y is equal to 4. So let's see what the answers are going to look like. Well, we start off with our initial statement. Y is going to be equal to 4. And then, so if that's true, then what's going to happen is I'm going to multiply by 3 on both sides, and that equality is maintained. So 3 times y is going to be equal to 3 times 4. So from there, I can say, all right, well, I can actually evaluate the 3 times 4. And so what the final answer ends up looking like is just this 3y is equal to 12. And so there's what I get whenever I apply the multiplication property with 3 to the expression y is equal to 4. All right, so now let's again apply the addition property of equality. And we want to use -3 this time. And what do we want to apply it to is x plus 5 is equal to 13. So let's see what the solution to that's going to look like. Well, we start off with our initial expression, so that's going to be our x plus 5 is equal to 13. So if this is true, then we know something else is going to be true, that if we add on -3 to both sides, so if we add on -3 to both sides, it maintains the equality. Now, something that I can do further from there, I've got these like terms, so I can combine the like terms, the 5 and the -3, and I can combine the 13 and the -3. And what that will end up giving me as just my final answer is just my x plus 2 is equal to 10. So if I've got 5 plus a -3, that's going to be a positive 2. And 13 plus a -3 is going to give me 10. So if I apply the addition property of equality with -3 to an equation, x plus 5 is equal to 13, I get x plus 2 is equal to 10. All right, so let's apply the addition property of equality. This time, we want to apply it with 3x, and we want to apply it to our expression 2x plus 4 is equal to 9. And so what's that solution going to look like? Well, I'm going to start off again with my initial expression, 2x plus 4 is equal to 9. And then what the multiplication, or what the addition property of equality tells me to do, is that I can add 3x to both sides and I can maintain that equality. So that's exactly what I do. I add on 3x to the left side and 3x to the right side. Now, kind of the next thing that I want to do is I want to rearrange these expressions to put like terms together. Now, over here on the left-hand side, 9 and 3x, they're not going to be like terms because the 9 doesn't have an x on it. Over here on the left-hand side, the 2x and the 3x are going to be like terms, but the 4 is not. And so if I want to put the 2x and the 3x together, I swap these two around. And so if I do that, here's what happens. I get a 2x plus 3x is equal to 4, and I get a 9, and that's going to be equal to still my 9 plus 3x. So now for the next step, because I've got these two like terms together, I can use the distributive property, which tells me that I've got an x times the 2, and I've got an x times the 3. Well, the distributive property lets me take those out of the of each expression, and I'm really just adding the 2 and the 3 together. And so what happens then, as kind of my final answer, the 2 plus 3 go together to give me the 5x plus 4 is equal to 9 plus 3x. And so I'm really taking just the 2x plus 4 is equal to 9. I'm adding 3x onto both sides, and I'm getting a brand new expression that's also going to be true. So if this one is true, then this one is also true. So this has given us a few examples of using the addition property of equality, the multiplication property of equality, and I hope this will give you a little bit of guidance in working the homework for this week, and I will see you guys next week.